Hi, my name is Taylor Odell. I'm a software engineer working with things like React, TypeScript, GraphQL, CSS, full stack web. Recently, I had the opportunity to interview Ryan Carniato, who created the Solid.js framework. So this talk came out of that. This is a high-level intro to Solid.js, reactivity, and then an impractical comparison to another popular front-end JavaScript framework. First of all, has anybody used Solid.js professionally? No, just played around with it. Cool. Well, then this will be very educational for everybody. Solid.js is a reactive, more on that word in a second, front-end JavaScript UI framework created by Ryan Carniato, open source in 2018, where you write solid components in JSX, sort of like React. But unlike React, there's no virtual DOM, and instead a compiler is converting your solid components into vanilla JSX and hooking that up to the real DOM. So what does that look like? Well, this is a functional component that allows you to display and navigate between a set of tabs. And the key thing to look out for here is this create signal function. And signals are essentially wrappers around values that observe that value, and as it changes, updates your DOM as it changes. So here we have the li's class name observing the active tab that is selected. And then when that changes, we're changing the styles. And this is fine-grained reactivity. And this fine-grained reactivity is what powers Solid.js. There's a couple of reactive primitives that allow you to create this link between data and display. We're going to look deeply at create signal, but you can also derive signals from other signals, and you can handle effects. You can memoize things. But functional components are only called once, and the Solid compiler is linking your data to your UI. And this fine-grained reactivity is what leads to high performance. But why? Let's take a simple comparison here. Here is that same set of tabs that we can navigate between, but written in React. And who can tell me how often this console.log is going to fire? Yeah? You can't see it? That makes sense. That makes sense. Excellent feedback. It's going to fire once on mount, and anytime the state below it changes. So I'll navigate between tab 1 and tab 2, and because React is looking at the state, seeing that in that DOM node in the virtual DOM tree, the state has changed, it's going to throw out everything from that DOM node below and re-render everything in the virtual DOM. Not only that, but even though we're only navigating between tab 1 and tab 2, tab 3 is also re-rendering. You can see there's a little console log here for tab 3. Why? Oh, you got to ask React. But you can get around this. You can cache this value. But this is a pretty intuitive way, I think, to write React components. So we were just looking at a React version of this tabs component where you can navigate between. We're seeing that we're re-rendering. And so this is in comparison to writing the same component in Solid. Your components are now only called once unless you're listening to a signal. So the only time that we'll see this console.log in Solid is once when the component is mounted, and then anytime if you depend upon a signal, you can obviously use an effect to call your console.logs. But now when we're navigating between tab 1 and tab 2, the only part of the DOM that's actually updating is what is listening to that signal, the active tab. So this is the simplest possible case that I can show you, that I can think of to show why Solid.js might be more performant. Let's look at a less simple comparison. When I was a kid, I was really into games like this and this and this and this. And then if I didn't use programming, if the same part of my brain that enjoys programming it wasn't also being used, I would enjoy games like this and this. I actually played a lot of this one, and then this one is a real monster I'd love to play sometime. But what do these games all have in common is they're all simulation games, and especially older ones are top-down isometric simulations. So I built a top-down isometric simulation in Solid.js. This is, well, I'm from Pennsylvania. And in Pennsylvania, the Christmas season lines up with the winter. And one Christmas season, I worked at a Christmas tree farm. And just like in real life, if you left-click on a tile, Also, yes, Taylor Swift is also from Pennsylvania. And she worked on a Christmas tree farm? No way. Oh, I'd love to be the Taylor Swift of Sydney. I'd have a lot more money. So 1 to 5 seconds after you place a seedling, it'll become a sapling. 1 to 5 seconds after that, it'll become an evergreen tree. And on the Christmas tree farm, we would use saws to take down our trees, but because this is a lightning talk, you can right click and it will clear the tile and set the loop up again. Now, sometimes on the Christmas tree farm, it would snow. And so what this is 1,000 divs, all with a position, a top and a left that is updated in a request animation frame loop over and over. And it has a rate, so you have this little parallax effect. So some of them are moving faster, some of them are moving slower. But this became my point of comparison, my impractical point of comparison to React. So I rewrote this in React. And then this performs slightly worse. And I'll tell you why. It's because every Snowflake component is handling its own state. So every Snowflake component has its own signal in Solid, and every Snowflake component has its own use state in a hook that has to run through a loop in React. And this is working against the way that React really wants to work. I've thought, oh, this is an unfair comparison to React. So then what I did was I rewrote it again, but I batched the updates. So instead of each individual Snowflake not checking out, I can't type and talk at the same time, handling its own state, there is now just one Snowflake's array that is updated in a batch. And that performs slightly better. And then I did the same thing in Solid to see how that would perform. And what I found was that actually in npm run dev, in Solid, this is working against Solid's principles. You don't want to have one big batched update. You want to have fine-grained reactivity so that every component is handling its own signal and listening to that. Yeah. So let's jump back to the slides, and I'll show you the code for what that looks like. Yeah, here's the batched update. Both of these are in Solid. On the left, we are calling the getter for all the snowflakes, creating a new array, and then setting that into the signal. And on the right, we are looking at each snowflake, getting that value, and then setting it. And that's actually the most performant of the 4 that we'll see. And then we're doing the same thing in React, where we're batching the update in one state call, and then in the individual update is a finagly, and I would not recommend that. So what can we draw from our conclusions? Solid.js utilizes fine-grained reactivity to hook up your UI to your data. Importantly, components are only called once. This was really helpful while writing all these loops. You can use set interval, set timeout, and request animation frame at the top level of component. And that sort of facilitated creating this animation. But the most important thing I learned is to align your framework with your design, because I was sort of trying to backfill this Solid.js fine-grained reactivity model and fit it into my React knowledge. And as I did that, I realized that that was not very performant, so I ended up going down all of these tangents. For some further reading, I would definitely recommend checking out the Solid.js docs. They're great. Hands-on Intro to Fine-Grained Reactivity is written by Ryan Carniato. That really helped me understand reactivity. JS Framework Benchmark is a much better way to compare frameworks. And Solid, and this is the interview that I did with Ryan Carniato for the Software Engineering Daily podcast. Finally, if you have found this talk educating, entertaining, edifying in any way, I'm looking for work. That's my portfolio, taylornodell.com. It's kind of a portfolio platformer. I almost did this talk on this, another interesting performance conversation there. That's my GitHub if you want to look at the code for both of these demos. That's my email. That's my LinkedIn if you'd like to connect on LinkedIn. I think I'm over my time, but if there's any questions, and if we have a minute, I'm sure I could take a question from the magical speaker box. Yeah, we have a couple. Yeah.
Yeah, not sure if you can answer this because it's a bit in depth, but
Sure.
I remember I think Dan Abramov was talking about in comparison with React to Solid
Okay.
that he was saying that Ryan at one point was talking about Solid's performance falling off a cliff because with signals it had more of a push model than React's pull model, in that when you got too many updates, it would just brick the updates because it'd be trying to jam too many updates onto the dominant ones. I'm not sure if, do you know if this is still the case with Solid? Because this was a few years ago, and I was looking at the TC39 proposal for signals.
Okay.
And they have like a push-pull model. I don't know. Did you go into depth?
I am not up to date on this. I will tell you that at 10,000 snowflakes, it doesn't really run that well.
Yeah,
It was
yeah.
like
No,
6 FPS, but it didn't stop. So
I
yeah.
tried doing a game of life in it
Yeah.
a few years back, and it didn't work.
Didn't hold up?
No.
Oh, interesting. Yeah.
Anyway.
Yeah. Thank you.
Thank you.
All right, anyone else? Nope. Okay.
Great. Thank you so much.
Thank you.
Please welcome. Yeah, please thank Tyler for his time.